Today, normal distribution. You should, oh dear God, at this point of the game, recognize that curve. If you don't recognize that curve, you might want to transfer out that semester. Yeah, negative cosine? Not bad, huh? This is your normal curve. It is your standard normal curve. It has a mean of 0 and a standard deviation of 1. The way that we did this before, we used this thing called a z-score, and z-score took our actual data and kind of put it onto a normal curve. It told us, what the z-score did is it told us how many standard deviations we were above average or below average. And you should have a pretty good gauge of positive 3 standard deviations to negative 3 standard deviations and what that means. If you are 2.5 standard deviations above the mean on a test in this class, you should feel pretty good about yourself. Why? Because you did better than most people in this class. Does that make sense? If you were at 3 standard deviations below average, -3, you should not feel too good about that test because most of the class is better than you. That's kind of where we left it before. Everybody kind of remember that conversation? Said, make sure you file that back away somewhere. It's important. It's a big deal. We'll come back to it. Yes? 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 Okay. So, today is the day that we're coming back to that stuff. Here's the information you need to get. I know it's small print, so I'll read it for you. Normal distributions are widely used because they provide a reasonable approximation to the distribution of many different variables. Okay? Again, we looked at the binomial distribution. Binomial work for those discrete random variables. That's where we're talking about specific things. Now we're going to look at the normal distribution, and we're going to look at continuous data. So normal distributions are continuous probability distributions that are bell-shaped and symmetric. As with all continuous probability distributions, the total area under any normal curve is 1. All those probabilities will sum to 1. Okay? For those of you guys who come from Calc, you have points of inflection at every breakpoint for standard deviation. It's just kind of interesting if you're into that. If not, if that's over your head, don't worry about it. This is the nuts and bolts about it. Okay? All normal curves are bell-shaped and symmetric. Continuous data. Lots of variables that we can use here. Lots of different things. Total what part?
Oh, area.
Area. Total arm. It does look like arm. A total underarm under any normal curve is 1. No, total arm. I did say area, and area should better make a lot more sense than arms. We haven't had a lot of graphic arms in there. It does look like arm. Okay. Z-curve. It's our perfect normal curve. What we do with our data set in class, is we norm it. When you hear data being normed, it's creating z-scores. Z-scores tell you how many standard deviations above and below. Make sure you're okay with this statement. It tends to show up as multiple choice test questions on AP exams. Every single normal curve is bell-shaped. There are other things that occur that can be bell-shaped. Just because something is bell-shaped doesn't mean it's normal. Okay? For example, we're going to learn about a t-statistic. The t-statistic is also bell-shaped. That is not a z-score. That is not a normal table. It's not a normal distribution. It's a t-distribution. Although it will look very similar.
So it's like the whole thing where like a square is a rectangle.
Yes.
A rectangle is a square.
Yes, perfect. All squares are rectangles, not all rectangles are squares. Okay. Kind of same thing here. All normal curves are bell-shaped, but not all bell-shaped curves are normal. Good analogy. I haven't heard that. Makes a lot of sense. Works also. I saw a family tree once of quadrilateral figures. It's pretty funny. If you remind me, I'll show it to you guys.
I know.
All right. To review from where we've been before. Suppose the mean test score for Chapter 1 is 79.5. Standard deviation is 11.4. If your score is 92, what is your z-score? Okay? Z-scores. Actual minus average divided by standard deviation. That's your z-score always. Actual minus the average divided by the standard deviation. So right now, everybody real quick, make sure you're familiar. You can calculate that z-score. You have done this before. It was long ago in a galaxy far, far away. So that's why I'm asking you to do it again. Plug things in correctly. In this case, you should realize that your score was X. That's the actual data point. The average or the mean is X bar. That is 79.5. And let's see, the standard deviation is 11.4. Very formulaic, very much plug and chug. I will tell you, please make sure you get the things in the correct places, because positive and negative screw you up. 92 minus 79.5 divided by 11.4. That's the correct setup. And I don't know what it comes out to be. What is it? Okay. 1.09649. In this case, some clarification about sig figs. Yes, that 0 is significant. It is a significant figure. So when I talk about 4 decimal places, you actually only need to take it out to here, the 0.5. Actually, you only need to take it to 6 because that's 4 sig figs.
So is it 4 sig figs or 4 decimal places?
4 decimal places is general rule of thumb. Where'd that come to? Rounding to 4. Because I erased it over there. That's sig fig, so I should take one more. What's that? 5? 4 decimals. Okay. So this person scored about 1 standard deviation above average. Pretty good. Agreed? Good. Next piece of information, when I say make sure you almost make a table like this, because here's the most common mistake. Realize that's calculating something completely different. That one says the average on the test was 92, and you scored the 79.5. So this z-score will come out to be negative. Which will tell you your below average. But you know if I scored a 92 and the average is 79, that can't make sense. This is part of making sure that when you're doing your calculation, that your actual output matches with what you know should be true as described in the situation. Does that make sense? We call that number sense, basically. Really? Questions, clarifications, or do we remember how that went? All right. Let's do this real quick. What time are we out and what time is it?
1:07.
What's that? We're good. Okay. All right. Reviewing. Finding the area under the curve. You need to use your charts for this. I'll wait. You needed to use your charts for this. The area under the curve. If you had negative 1.63, if you take out your formula sheet right now and find the z-curve, I highly recommend you do that. You're looking at the z-scores. This is negative 1, 0.0, negative 1.2, negative 1.3. It kind of goes all the way down here, and this one takes you to the hundredths. You want to find the area. So here's your z-curve. I'm going to draw it a little bit lower. I want to find the area there. And your table goes from left to right. So it will report, if you tell me what negative 1.63 is, that will be the area under the z-curve to the left. And I'll make sure that this drawing that I have written here makes sense when you look at that off your formula sheet. And what is that area? I don't know what it is. I have to look at the formula sheet. What is it? 0.0516?
Yeah.
Does everybody get that? Make sure it matches up? Yes, question. All right. My next question for you guys. I want you to use your charts. How do you find the area to the right of negative 1.45? Now notice this question is asking me to find this area over here. How are we going to find that? You can't. It's not going to be on the next page. Your negatives are on the one page. Your positives are on the right on one page. The report only gives it to you from the left to the right. What do we know the whole area has to be? 1. If I know the area on the left, can I figure out the area on the right? 1 minus the area on the left. So go ahead and find that probability right now.
Was it really?
What's that?
It's close enough.
Minus the negative, so that
All right, you have that probability with 1 minus.
0.037. Just kidding. 735. 0. Yes. So no, it's negative 1.45. 0.735. Isn't it more than 1 though?
You guys have answers?
Yes. Isn't it more than 1? Isn't it not more than 1?
No. Everything under there is times to 1.
It's over 2.
That's a negative z-score. It's a negative standard deviation. Let's see. You guys get something like this? How many of you got stuff like that? 0.9265. If you got 0.9265, get your round, give yourself a little pat on the back. You're seeing how this stuff works. That's a good thing. Don't slap yourself that hard. Okay. Does everybody see the connection to your standard deviations in that curve? Speak now or forever hold your peace, because this is kind of a big deal. All right, go. to get to 0.9265. The total area under the whole curve altogether will always be 1. So what I did was found the area on the left by using my table, and negative 1.45 came out to be something like 0.0.
0.0735.
Okay, this area here was 0.0735. That's that area. So like the idea of using a complement, if I want the area over here, then I'm going to go 1 minus the area on the left, and that will give me the area on the right. Okay? So, here's the deal. What does the word cumulative mean in terms of binomials and geometrics? What does that word mean? Adding up and including. Agreed? Okay. Next big test for you guys. Can you guys remember to go from left to right? Can everybody remember to go from left to right? It's how we read. So you're agreeing with me that you can go left to right?
Yeah.
Okay. And cumulative means up to and including. Agreed? Okay. So here's what I want to show you. Press second distribution. And now, are we dealing with a binomial or a geometric distribution? Neither. This is a normal distribution. Oh. These aren't hard questions, people. These are the easy ones. Okay. We want a normal. You will never use normal PDF. Everything we will use is normal CDF. Okay? Normal CDF. I told you go from left to right. Always left to right. I want you to hit normal CDF right now to pull up something like that. And on this problem, do you agree with me? I'm looking at the blue. We want to go from the left end of the graph. We want the area from the left end of the graph all the way over here, all the way up to negative 1.63. Everybody agrees with that? So, we've talked about standard deviations, negative 1, negative 2, negative 3. Okay? Is it safe to say negative 100 standard deviations away is pretty much all of our area? If I was negative 100 standard deviations below, not really going to exist? Is there going to be probability out there, really? It's going to have so many zeros, it's not even counting, right? Okay. So I'm going to go from left to right. So if this makes sense to you, I want to know the area underneath the curve from negative 100 standard deviations all the way up to negative 1.63 standard deviations. Does that make sense? CDF cumulative, up to and including. Negative 100 to negative 1.63. Put that right here. Negative 100, and by the way, make sure you use the negative sign, not the subtraction sign, because you'll get an error if you put the subtraction sign. Negative 100, comma, negative 1 point, what was that point? 63, close the parentheses, and oh me, oh my, that should be a very cool number for us. Keep that at 0 and 1 always. Enter. 0.0516. What does that round to? 0.0516. Oh, that's kind of a nice thing. Why didn't you just show us that button in the first place? Here's why. You actually need to understand what that calculator is doing. Okay, remember what I said. You guys told me you can all read from left to right. For the red one, we want the area from the left to the right. We don't have to even do that. I now want... Exactly. Norm CDF, the area from negative 1 point, what was it? Oops. I didn't press the right button because I'm retarded. There we go. Norm CDF from negative 1.45 up to 100 standard deviations.
What's an error?
Close it. 0.9265. And isn't that what we came up with using our chart? Okay? I would, because, again, you can actually get away with negative 20, negative positive 20, negative 5, positive 5. Yeah. Watch, when I show it, I'll do one right now, the 10.
You would never do PDF.
PDF, and what did I say? It's negative 1.45. We do it to 10.
No, it's just an error.
Oh.
Again, notice that even beyond, but we know that 99.7 is the 3 standard deviations. So to get out to 10 standard deviations, to get out to 100, 100 is going to get, you've got it covered. You see what I'm saying? And I used the 100 to make a point that we're going for. All right. Can we see how that works? Do we like that button on the calculator?
Yes.
Yes. Do you see how that button on the calculator connects to our normal curve?
Yes.
And finding the area of the curve, because here's the next step. We're going to use it to find the probability of things. For example, I don't want to do that one. I want to do this one. Consider all 1-gallon cans of Dusty Rose paint. I painted over the weekend, and the color of the room was Dusty Rose paint. Suppose that it has a normal distribution of 5 milliliters, and a standard deviation of 0.2. X is the amount of red dye they add to the white paint in order to make it Dusty Rose. Okay? So they have a little machine that measures 5 milliliters. But we know that machines are going to err sometimes. It's supposed to put 5 milliliters in. Sometimes it's going to put a little bit more. Sometimes it's going to put a little less in. But that more and less is going to be normally distributed around the 5 milliliters. So now I want to know, what is the probability that if this is what the machine's doing, that I get a can of paint that has less than 5.4 milliliters of red dye? So here's how you have to do. We're going to use the normal distribution to find that probability. I'm looking for the probability that X is less than 5.4 milliliters. Do we agree? Notice that's the same kind of thing that we're doing before. Notice that this data is now continuous. 5.4, 5.5, 5.6. It's not discrete. I have a normal curve, and you will always sketch the normal curve for full credit. I have a mean of 5, and I have a standard deviation of 0.2. I want to know less than 5.4. 5.4 is above. I want less than that. So you will shade the probability that you're trying to find. It should make sense to you right now that this probability had better be better than 50%. Because 5.4 is higher than average. So the probability that I get a can of paint that has more than less than 5.4 when my average is 5, there should be a relatively high probability of that happening. Mr. Wood, I don't know how to put this into my calculator, but you do know how to norm your data using the z-score. Actual minus what's supposed to be divided by the standard deviation. So your z-score will be 5.4 minus 5 divided by its standard deviation, which is 0.2. The new calculators will let you input it for you. I will tell you on the AP exam, if you don't write the probability statement and you don't write the z-score setup and you don't write the graph, you will not get full credit for that. So in order to get full credit on the AP exam, these are the things you need. Your calculator shortcuts it too much for you. Yes? In order to get full credit. On multiple choice, it doesn't matter. On free response, you need this. So your z-score comes out to be there, what? 2. Finish up the problem. This is for full credit. Should it show up? And this shows up frequently. What are we going to do? We will norm CDF. And again, we're going to go from left to right. So that's going to be negative 100 to 2. And that probability will be the probability that I go and get a can of paint that has less than 5.4 milliliters. Should be a high probability, by the way. No, we will not always go for negative 100. In this case, we will, because you always go from left to right. So sometimes the left is not going to be negative 100. Sometimes the left is going to be here. Sometimes the left is going to be here. It's good. The context of the problem. Like my next problem, or I'm going to do a problem in a second. I want to know the probability it's going to be between like 4.8 and 5.2. So I'm going to have to find two z-scores. And then my left is going to be below one, and my right is going to be get into that. Night.
I know Randy was a PDF.